say that 2 raised to a power equals 8, we're all pretty familiar with this, and we know that the power is 3. But what if I asked you 2 raised to what will equal 6? Okay, it's definitely not to the third power anymore. And the only way that we can actually calculate this out is to do a logarithm. And logarithms are in this general form. So we have the log with a little base of a number equals x. And how we transform this into an exponential form would be the little base raised to the answer out here, and it equals the bigger number. We're going to rewrite some of these logarithmic form problems into exponential form, just to get the practice of it. So we're going to take the little base, we're going to raise it to the outside number of the equal sign, and that has to equal the number here. And it makes sense. 2 to the third power equals 8. Number 2, same thing. We're going to take the little base, raise it to the second, and that has to equal 16. And this also makes sense. So this is how you would transform a logarithmic form into an exponential form. Now we're going to evaluate some of these in our head. When we do this, remember we have to set equal to x, especially if we're figuring out what that exponent has to be. So we're going to take the little base, raise it to x, and it has to equal 64. Then you have to ask yourself, what exponent of 4 will give us a 64? 4 times 4 times 4 will be 64, so 4 to the third power. So in this case, the exponent has to be 3. The next one, we have a base of a 36. So we're going to take that, raise it to an x, and this time it's equal to 6. Notice how we have a bigger number going to a smaller number. So we're not going to be raising this 36 to an exponent that is a whole number. Instead, it's probably going to be a fraction, which a fraction is really known as a root. So if we're going from 36 to 6, that rings a bell and says, I'm taking the square root of that number. And the way to express a square root as a fraction is a half. So I know that the exponent has to be a half in order for this to work. Now there is an easier way of doing this, and it's called the change of base formula that you can use every single time without having to do it in your head. And the change of base formula says we're going to take the log of y over the log of the little base and divide them. So if we were to do this in our calculator, we would do log of 64 divided by the log of 4. And if we do the number 2, 1, we would set it up by doing log of 6 divided by the log of 36. Now if you go to your calculator, the log button is located right by the 7 here. So we're going to do the first one, log of 64, and you want to end your parenthesis, divided by the log of 4. And the answer is 3, so you can see that we do get this every single time. And now let's do the second problem. We have the log of 6 divided by the log of 36. And we get 0.5, which if we do math enter, that fraction is a half. Okay, so this is a way to do it in the calculator. You more than likely will like this way a lot better. Now in your calculator, you notice how they have a log. There's no little base or anything there. And what the log in the calculator means is that there's a base of 10. So if you ever see just a plain log by itself, the base is 10. They just don't write it because it's so common. And then over here we have the natural logarithm. That's when we have the log of that Euler number. And instead of doing the log of base e, because we can't do that in the calculator, they give us a way to do that, and it's the ln button. And the ln button is directly underneath the log button. So if we're going to evaluate these, we just type in our calculator, log 8. And the calculator will give you a very long decimal number. And if we want the ln of 0.3, we type in ln 0.3. And again, it gives you a very long decimal number. So this is used when we're evaluating these. Keyword is evaluate here. Now, we're not always going to have it that simple. When we don't want to evaluate the actual answer out, we want to simplify the expression. So let's say we have the log of base 5 and then 5 to the x. Whenever you have a base that matches this number here, it cancels out. And whatever you're left with will be your answer. So the answer here is x. Let's do another one. Number 2. Again, we have a 10 raised to log base 10. Remember that if it's not wrote there, it is a 10. So in this case, if you feel like writing it in, you could. This also will cancel out, and if whatever's left over will be your answer. And number 3. What if you have a base, but this number doesn't match? Well, more than likely what you can do is you can rewrite this so that it does match, but 2 raised to what power is 32? Fifth. So, and then just drag down your x. Now you can tell that these will cancel, and you're left with 5x. Now we're going to find the inverse, and we've found the inverses of other functions as well, and it is the same exact process. So we're going to switch our x and y around. So now we have x equals log base 8 of y. Okay, and now we want to solve for y. Anytime you want to get rid of a log with a base that is there, you take that base and you're going to make all of this an exponent. So over here we'll have an exponent of x, and this will be an exponent as well. Now you can tell the 8 and the log 8 will cancel, and we're left with y. So we have y equals 8 to the x power. We solved for y, and it's done. This is an inverse, so we'll write the little -1 on top. If you look at number 2, we're going to switch the x and y around just like normal. And we need to solve for y. Now, whenever you're solving for y and you have an e, the opposite of e is the ln button, the natural logarithm. So, just like adding is the opposite of subtraction and will cancel each other out, the ln of e will cancel it out. So we're going to take the ln of both sides. And because we took the ln of an e, it cancels out and we're left with y plus 2. Now we still haven't solved for for y. The only thing we need to do is subtract the 2. So if we subtract 2 on both sides, we have ln of x minus 2 equals y now. Now it's solved for y. This is our inverse. We'll put the little -1 up top.